Today we'll see a small topic about structural analysis, that is static indeterminacy and kinematic indeterminacy. Generally, a structure can be determined as a determinate or indeterminate structures. The main difference between determinate and indeterminate structures are determinate structure mother conditions of equilibrium mattum it will be sufficient, whereas in indeterminate structures compatibility conditions are required. Next, when coming to bending moment and shear force, in determinate structure bending moment and shear force will be independent of cross sectional area and flexural rigidity, whereas in indeterminate structure it depends upon the cross sectional area and flexural rigidity. When coming to stresses are caused due to no stresses will be caused in determinate structures, whereas in indeterminate structures stresses will be caused due to temperature variation, lack of fit or differential settlement. Determinate structure can be used as such, whereas in indeterminate structure the structure should be converted into a determinate structure. Indeterminacy is mainly classified into two types, that is static and kinematic indeterminacy. Static indeterminacy will be external static indeterminacy and internal static indeterminacy. Formula for static indeterminacy is specified as SA or DS. Formula is external static indeterminacy plus internal static indeterminacy. To find external static indeterminacy, it is based on support conditions. For 2D structures, external static indeterminacy is RE minus 3, and for 3D it is RE minus 6, whereas RE is total external reactions. This external reaction comes from the support. Next is internal static indeterminacy. Formula to find internal static indeterminacy is when the structure is a truss. For 2D it is m plus r minus 2j. For 3D truss it is m plus r minus 3j. Rigid frame structure, for 2D it is 3m plus r minus 3j. For 3D it is 6m plus r minus 6j. Here m is number of members, r is number of reactions and j is number of joints. Truss can also be said as pin jointed frame. See, here I have given a small example, like support based on support conditions external reactions are taken. When it is fixed, we will be having horizontal, vertical and moment. That is here 3 and here 3 external reactions will be 6. 6 minus 3 will be 3. Next, here is fixed and this is hinged support. There will be two conditions, horizontal and vertical, whereas for roller support will be having only one condition, that is vertical condition. And when a beam is supported by a hinge, when a hinge is present in a beam, in such type of conditions static indeterminacy will be determined as here 3 and here 3 comes 6, 3 minus n minus 1, here minus n minus 1. This n is number of members meeting at the hinge. Here the number of members meeting at the hinge will be 2. Here the hinge is this one member, this one member. So number of members meeting at the hinge is 2. So static indeterminacy will be 2. This is for frame, simply supported frame. 3m plus r minus 3j. Number of members is 3. Reactions is 6. And number of joints is 4. So static indeterminacy is 3. This is about static indeterminacy. Next we'll see about kinematic indeterminacy. Kinematic indeterminacy is generally also called as degree of freedom. Kinematic indeterminacy can be calculated simply, that is by taking the movements allowed by the supports. See, for fixed movements there will be no fixed support, there will be no moment in it, so it is 0. Hinged there will be moment, so it is 1. Roller there will be horizontal moment, force and moment, so it is 2. When it is a free end there will be 3. Fixed beam is also always it will be kinematically determinate, whereas simply supported beams it will be kinematically indeterminate. For 2D frame or pin jointed frame or truss, kinematic indeterminacy can be calculated by 2j minus RE. RE is number of reactions. For 3D it will be 3j minus RE. This is something about static indeterminacy and kinematic indeterminacy. We'll continue about this in next video. Thank you.